Hello and welcome to this short tutorial which will cover the design spreadsheet for the concrete slab design to Eurocode 2, which is available from my website. So in order to get access to this website, to this spreadsheet, just click on this icon here to download the zip file. You'll need to extract the zip file, and inside that will be a PDF worked example and the Excel spreadsheet itself. And in this tutorial we're just going to cover the spreadsheet on its own and not the worked example. Okay. So I've already got the worksheet open down here. If we go to project info, this will be the page that you'll see when you first open the spreadsheet, and there'll also be like a little disclaimer which pops up. The little disclaimer is basically there to say that you should be using your own engineering judgment and making sure that all of the inputs and all the outputs from the spreadsheet are as expected and sort of fit with what what you should be designing. And that's true for all of the spreadsheets on my website. You should be using your own engineering judgment when using all of them and making sure that you're happy with the results that you get out of them. Okay. So with that said, we can have a look at the first sheet that you'll see, and the first sheet of interest is the project info sheet, which is this one here. And on this sheet you can enter all of the project information for the project in question. So here I've just filled out some sort of example information here. You can add your project name, the project number, the client, who it was made by, who it was checked by, and the date. And obviously in here we can click this button to add today's date, and if we click on the reset button here, it's just going to empty all of these cells back to nothing again. Okay, so that's what this sheet does. So moving on, we can go to the design sheet at the bottom here, and the design sheet we can auto populate our header here with the information that we previously filled out on the project info. So if I click on auto fill header information and hit yes, it's going to populate all of the information that we put in from before. And I can also put in a description here for the concrete slab that we want to design. So I'm just going to call this concrete slab 1, like that. And I should also mention before going any further that all of the cells in light yellow are input cells, and all of the cells that aren't in light yellow are basically headers and things that you shouldn't be messing with. Okay. So moving on, we basically now got the input stuff, the input data for the form that we can fill out. So I've labelled all of the headers in here in order, which basically means that you should go through these in order to fill them out, really. That will help you the most in terms of how to enter all the information for your concrete slab that you want to design. So the first one we come to are the analysis options, and then here we can basically turn on or off different parts of the analysis that we want to consider. So for example, you may not care about calculating crack widths, and if that's the case, we can just turn these off, for example. Okay, just turn those off, those crack widths. In this case I'm going to leave them on, but that's basically what you can do. And you can also turn off the L over D deflection check. For example, you might have a ground bearing slab, and in that case you wouldn't be as concerned about the L over D deflection check in that instance. Okay, so it just gives you a bit more latitude in terms of what you want to include in your final design. Okay, moving on. We've got the concrete properties, and these are the concrete properties at 28 days and onwards. So these are the concrete properties for the sort of the final building, not for a temporary stage. Okay, if you're doing a temporary stage slab, this is not the spreadsheet for you. You should be looking at some more in-depth analysis and probably your own design. Okay, so this is for a permanent condition. We can select in here our concrete grade, and I've got a lot of the typical concrete grades, but we can also select manual down the bottom here if we've got a custom concrete grade. And if we go custom, it will allow us to put in our own characteristic cylinder strength in here, so we can add in our own value. I'm not going to do that. I'm going to stick with the C2835. Okay, and with C2835 our characteristic cylinder strength is 28 newtons per millimeter squared, or 28 megapascals. So that lets us set our strength of our concrete, and these values down here underneath are the automatically calculated values for the mean compressive strength, the mean tensile strength, and the mean modulus of elasticity. And again, these are all at 28 days, all of these values. We can also set our aggregate type, so we can have quartzite, limestone, sandstone, or basalt, and these will affect our modulus of elasticity value. You'll notice that if I pick limestone, it's going to drop. If I pick basalt, it's going to increase. And this is in accordance with Eurocode 2 on the page previous to table 3.1. So if you go there, it will have a bunch of information about why these values are lower for different types of aggregate. And finally we have our aggregate size, and this is used when we're looking at the spacing of our reinforcement we want to have a maximum aggregate size of 20, and that sort of determines how widely spaced our reinforcement can be. Okay, so that's what that's doing. Moving on, we have our reinforcing steel properties. So we have the characteristic tensile strength. This is normally 500, okay, but you can obviously add that, change that if you want. And the modulus of elasticity of steel, which has been set as 205,000 units per millimeter squared, or megapascals. And so these two values are sort of typical default values, but I have allowed you to change them if you so wish. Okay. The next panel is the concrete slab geometry. So we have the concrete slab thickness, so we can change this to something bigger. And if I change that, you'll notice that this diagram down here for the slab cross section will change. So if I could make this really thick, it's going to make our slab really thick. Okay, back to 300. We have our slab span direction in the X direction and our slab span direction in the Y direction, and these are used when we're calculating our L/D deflection checks. Okay, that's all those are used for, these two in here. So you will notice that if I go back up the top here and I turn off my L/D deflection check, turn these to emit, it's going to turn off these cells in here because they'd no longer be relevant. Okay, turn these back on. You'll also notice that the slab width is set as 1,000 because essentially we're looking at a per meter width of the beam. Okay, we've got our slab support conditions, and again these two cells are only for the L/D deflection checks. So we can have simply supported, a slab on columns, an end span, interior span, and a cantilever. And these, depending on what you pick in here, will affect the K factor for the L/D deflection check. So if I go all the way down to the bottom where we've got our deflections, it will change this K factor in here. Okay. This is all greyed out at the moment because I've not put any loads in at the moment. But if I put some loads in, it will change this K factor here. Okay, that's what that's doing. Next we have our concrete cover. So this is the distance from the edge of the beam to the start of the reinforcing bar. So we can change this for the bottom reinforcement and the top reinforcement. So as an example, if I make this much bigger, you'll see the reinforcement at the bottom jump up in the diagram. So I'm going to change that back. And the next, that's the concrete cover. The next one is the crack widths. And again, this will be greyed out if I turn the crack widths off. So if I go back up here and I turn off my crack width in the assessment and go down, it's going to grey out my crack width inputs. Okay, so let's turn that back on again. Back up here. So crack width inputs, we've got our allowable crack width in here. You'll probably need to go to the Eurocode to see what crack width is, relevant for your project. But I have given some information here in the notes. We've got our type of the rebar that we're using, so high bond bars or plain bars. Typically high bond bars would be used. Type of loading, typically this will be bending for a slab. The number of days when considering the short-term loading. So this is looking at the crack widths in the short and long term. This one will let you look at the crack widths in the short term. So if you've got sort of early age cracking going on, so we can set this to lower than 28 days if you wanted to. So let's put that at 15 days. We've got our S factor for the cement type, and we've got our creep factor for long-term loading. So the creep factor will affect our crack width assessment when we're looking at the loading on the concrete above 28 days. So that's for long-term loading, and this one here, the T factor here, the number of days, is for the short-term loading. Okay, so that's what that's doing. And now we can put in our loads in section 7. So we've got ultimate limit state, which is failure, and serviceability limit state, which is serviceability. The ultimate limit state moments in here are used to check the capacity of the slab, so they'll be used for the moments and the L/D deflection checks, and the SLS moments in here will be used to check the crack widths. Okay, so let's just put in some values in here like that. Let's put in 10, 15, 10, 15 as just an example. So now we can go on to defining our reinforcement in the slab. So if we go up to the top here, we can see our reinforcing steel. And in this one, we can actually add quite a bit of information regarding the reinforcing steel. So you can add 2 lots of layers for each direction. So we have our bottom XX reinforcement, and so we can actually add in our reinforcement here. So we've got, at the moment, we've got H10s, so the 10 mil diameter bars spaced at 200 millimeters in the bottom one layer. But we can also add another layer in here. So let's add another bit of rebar. Let's put it at 200 as well. And now you can see this is also in the B1 layer. So effectively now we've got H10s at 100 millimeter spacing. And if I go down, you can see that here because we've got in black and pink, we've got those 2 lots of H10s. I can also put the H10s in the B3 layer if I so wish. So if I go back up here, I can put them in the B3 layer, and you can see it's put them in the B3 layer there. So that's what we can do for all of our reinforcement, and that applies for the bottom YY reinforcement, the top XX, the top YY. We can do that for all of them. Okay, so that's quite useful. I'm going to omit that bar there for the time being, and also show you what we can do with the mesh wizard up here. So if I open the mesh wizard by clicking on this button, we can actually input a standard mesh size for our reinforcement instead of having to go to the tables and work it out ourselves. So if I wanted to put in an A393 mesh, which is actually H10 to 200, I can go click on that to select our mesh type. It's going to tell us what the mesh is down here. So it says current mesh, it's a square mesh, and it's going to tell us that our main bars, this is the area of steel, our transverse bars, this is the area of steel, the mass of the mesh, and what the actual bars are, so H10 to 200. I can select the position in the slab that I want these bars to be added. So let's put them in the bottom. We're going to put them in the bottom XX direction, and let's put them in the L1 main and L2 transverse. So this means that the main bars of the mesh are going in the layer 1, and the transverse bars of the mesh are going in the layer 2. And we're going to have this as a main mat. We're going to add that to design. It's going to give us a summary of what we want to add, and then that's going to put it into here. And now it's not looked as if anything has changed because we already had the A393 mesh defined. So if I go back to here and pick a different mesh, just as an example, bottom XX L1 main mat. So this mesh would be H8 at 200. Add that to the design. Now it's added that in there, H8 at 200. Okay, so that's basically what's going on with there with our reinforcing steel. And basically that's it for the user inputs. The rest of this sheet will be auto calculated for you. So I'm just going to cover that briefly. So down here we have our summary of the reinforcing mass for the bottom and top steel. We have the depths to reinforcement from the top and bottom of the slab, which is used in the calculations which come up next. And now if we go down to the bottom bits here, so we have our geometric checks. This bit here checks the spacing between the rebar to make sure that it's actually we've got a sensible spacing for our reinforcing bars. This section here checks to make sure that the reinforcement actually is sensible in that it can actually carry the moments that we've applied. So to make sure that we don't need any more compression reinforcement, because this spreadsheet doesn't cover compression reinforcement. Okay, so that's a quick check there, a sanity check on the maximum moment that the slab can carry. And in this next section down the bottom here, we check our moments. So this checks both the minimum area of steel, AS min, the required area of steel against our provided area of reinforcement, and gives us a utilization. It checks our maximum area of reinforcement as well, and gives us a utilization of that. Next bit we have our deflections, our L over D check, and this obviously checks whether the slab is sensible for our deflections and gives us a utilization. And then moving on, we have our crack width checks, which is quite involved. And basically the crack width is split up into long and short term. So firstly up we have our constants, so these are values which don't change. We have our K factors from the Eurocode, we have our geometry, so depth to reinforcement and the areas of steel provided. We have our material properties, so the modulus of elasticity in the short term, which is this value here, the ECMT, the modulus of elasticity in the long term, which is the E effective, which accounts for creep, and then we have our modular ratio, which is basically the ratio of the modulus of elasticity of steel to the modulus of elasticity for the concrete, and we have that for both the short term and the long term, which includes the creep. And then we have also our equivalent bar diameter here. So this is all of our constant inputs, which won't change. And then we move on to looking at the crack width. So we have an uncracked section assessment without the creep, an uncracked section with the creep. Then we have a cracked section assessment with the creep, and a cracked section with the creep. Sorry, without and with the creep. So there's sort of 4 situations to look at, and then we go on and then we look at sort of what the worst case of these would be, which would happen. And as you can see, we're failing on the crack widths for our short and long term loads for the bottom steel. Okay, and then finally at the bottom here we have an assessment of the shear strength of the slab. So this is a linear shear, so this would be looking at, for example, a slab supported on a linear support, like a wall, for example. And then we also have the shear strength of the slab if we were looking at a punching shear situation. So this would be the shear strength of the slab along that punching shear perimeter. And these are provided so that you can get a quick idea of whether the slab will actually work if you're designing, up against the wall support, or if you've got like a column and you want to look at your punching shear. This spreadsheet doesn't do the punching shear assessment, but it does give you the capacity of the slab along that punching shear perimeter and along that linear support, which will help with your further calculations. And then we finally have a design summary which shows how the section is passing or failing for the different limit states that we care about. Okay, so that's the sort of overall design sheet. Once we have our design sorted out, we can then actually save this design to our Save Designs database down the bottom here. So we can save out all of our inputs in here, so we can continue to do multiple designs quickly. So the way we do that is the same for all of my spreadsheets. We go over here to the project controls, and if we want to append a design to the Save Designs database, we put a 0 in this box, and then we click on Save Design to Database. If I click on this, it's going to ask me, do I want to continue because the current design fails? In this case, I do want to because it's just an example, but obviously in reality, you'd want to go back and make sure your design is working before you save it to your database. So we're going to hit yes, and if I go to the Save Design database, you can see it's outputted all of the input data for that design into row 1. And if I go back to my design and keep clicking on Save Design, it's going to keep on exporting to the table, and it's going to keep appending to the table. Okay, let's just rename these quickly to help us. We can also append a design in this database. If I go back here and if I type in 3, for example, and hit Save Design to Database, it's going to ask me current design may already be in the database, so I want to overwrite. If I hit yes, it's going to overwrite our third design in that database. So it's going to overwrite this design in here. Okay, and you can see it has, because I'd relabeled that to be Concrete Slab 3, and when we saved it, it's overwritten that with Concrete Slab 1, which is the one that we have currently in our design sheet. So that's what that's doing in there. We can also reorder the designs in this database in here. If we go up to Select Design and pick a design from the list, so let's pick Design 1, which will be this one in here, and we can move it up or down in the sheet using these controls over here. So we can move it down, we can move it up, we can move it to the end, we can move it to the start. So that allows you to reorder all of this stuff in here. And then we can also load this design back into our design sheet. So if I select the design I want, which would be this one, Design 1, and click on Load, select the design back into Design Sheet, it's going to load all the information back into here. So we can quickly move between the two, save out a bunch of designs, and save a bunch of time. So that's what that's doing. I can also reset all of the data from this sheet. So if I click Reset Design Sheet, hit yes, it's going to delete, it's going to reset all of the information on this design sheet back to the defaults. Okay, so if you ever make a mistake in any of these defaults, you can reset it and get back to where you were, when you first opened the design sheet. Okay, so that's what that's doing. We can also PDF our current design if we click on this button, and not only can we set where we want to save this design as well on our server, so I'll cancel that. We can also set the print scaling down here as well. So at the moment it's set at 75%, but depending on your version of Excel and your printer settings, you may want to set this differently when you print to PDF. Okay, so that's what that's doing there. These further buttons down here in the Optimiser, these ones here are basically allowing you to put in a bunch of rebar up here and then optimize, find the best moments that you can apply to the slab that will work for that reinforcement. So if I show you that just quickly now, if I go down here and click on Optimize ULS moments for bending and LOD checks, it's going to find the moments in here that will basically give us up to 99% utilization for the current reinforcement that we've done. So if I click on that, it's going to give me these moments here, and if we scroll down you can see that these moments just about work for the reinforcement that we've done. And obviously this is very useful if you're designing a concrete slab using some finite element software, because what you can do is you can say, right, I want to use a mat of say 8/16s at 200, and then we can work out what our maximum moment can be for that slab. We can go back to our finite element software and say, right, I know that 8/16s at 200 can, the maximum we can carry there is say 50 kilonewtons or something, and then we can filter our finite element results to see what parts of the slab need a heavier mat or need more reinforcement. So sort of another way of approaching the problem, instead of putting a bunch of loads in here and trying to tailor our reinforcement to meet those loads, we can put in a bunch of reinforcement and find the loads that will work for that reinforcement. So it's another way of dealing with that. And of course in here, the Optimiser, these basically are doing the same thing, but all of these ones here allow you to do sort of different optimizations. So for example, we can optimize just looking at the ultimate limit state moments. We can optimize looking at the L over D check. We can optimize looking at the moments and the L over D check, and we can optimize looking for the serviceability state moments just for the cracking. So these first three buttons are basically looking at the values in in here for the ultimate limit state, and the bottom button here is looking at the moments for the SLS or serviceability limit state. Okay, so that's what that's doing. And then finally down the bottom here we have plot geometry in AutoCAD. And so what this is going to do, it's going to basically let us plot this section here in AutoCAD very quickly instead of us having to plot it by hand. So if I click on that, it's going to tell us that it's copied all of the geometry to our clipboard. Okay, and all I have to do now is go to AutoCAD, go into the command line and go Control V, and that should plot us our slab. And what it's done here is it's plotted two sections through the slab in here, which is why you've got two sections here. Okay, so that allows us to get your geometry into AutoCAD so you can quickly start sketching things up and preparing a set of drawings if you so wish. Okay, so that's what that's doing in there. I'm going to show you some more of the database tools as well in Excel. So if I go back to Excel and we go to our Save Design sheet, so I've already shown you all of the moving tools and loading tools. We can also create a summary table if I click on here, and what this is going to do is it's going to load in each one of these designs into the design sheet and then export all of the design data and also the utilizations to a summary table. So if I click on that, it's going to create our summary table in here in our summary sheet, and so you can see it's got all the designs, it's got a bunch of the geometry and what we've applied, but it's also got all of the utilizations as well. And we can print this sheet by clicking on print summary, and we can also set the print scaling to this sheet over here on the print scaling for summary sheet. So that allows us to do our summary. We can clear the table, we can update it, clear it, do what we want, go back to here to our save designs. We can also plot all of our designs in AutoCAD. So if I click on that, it's going to do the same AutoCAD command, but it's going to let us plot all of them at once. So I go back to AutoCAD, to the command line, hit Control V. It's going to have plotted all of those for us, so we can do it all in one hit instead of doing them one at a time, which is obviously very useful. And also in here as well, I can delete certain designs from this database. So let's say I wanted to delete design number 3. I could go over here, click on design number 3, and click on delete current design, and that'll delete it from the table. I can also delete all of my designs from the table. Okay, and then also as well I can reset the row coloring. So let's say for example I wanted to color a bunch of the rows in this table to help myself when I was sort of looking at a bunch of designs, and then I wanted to reset this row coloring. I can just click on that button and it will reset the row coloring back to this grey and white that we have as the default. Okay, and that's basically the entire spreadsheet. If you want some more information on sort of how all these calculations work underneath here, how some of the formulas were derived, and sort of how this all works together, I'd recommend referring to the Eurocode first and foremost. So Eurocode BSEN 1992 Part 1-1, but also look at the PDF worked example, which basically goes through every single calculation, every single formula on this spreadsheet, and also shows you how some of the more tricky formulas are derived. So for example, how we derive this cracked neutral axis depth and also the second moment of area, because those ones aren't explained in the Eurocode and they had to be derived from first principles, and they are shown in the worked example in the appendices at the end, so they may be quite useful for you. Okay, I hope this was useful, and I'll catch you in the next one. Okay, bye bye.